Hi. Thus far, in our consideration of derivatives, we were using the concept of a limit. So now, let's say a little bit more about it. Okay, so look, to be more general, let's just say that for a second we're going to replace, we're going to denote difference quotient as Q, while we're going to say that V is equal to delta x. Well, is defined as delta x. Okay, so look, now we can rewrite derivative dy dx, or equivalently f prime of x, that was given by as a limit with delta x approaching 0 out of difference quotient delta y delta x. We can now write it as limit with v approaching 0 out of q. Okay, and now we're going to talk a little bit more about the limit. So look, we know now that we can rewrite the derivative in a simpler form by replacing difference quotient by q and delta x by v. Look, when we calculate limits, we use more general concepts. Look, so when we talk about the limit, we think about v approaching some value n, because n doesn't necessarily need to be equal to 0. As you will see, actually the limits that we calculate the most often are associated with either infinity or negative infinity out of q. And this is the expression that we're going to be dealing with for now. Okay, so let's go now to what does the limit represent. And look, over here I've written limit tries to answer a question. And look, I didn't write limit answers the question. Why? Well, because sometimes we have a situation that we cannot find the limit, or in other words, limit does not exist. So limit tries to answer a question, what value does one variable q approaches, so gets closer and closer to, as another variable v approaches some specific value in our context n. And limit is going to give us the answer to this question. But the thing here is that when a variable is approaching some specific value, it can usually do it from two sides. Look, if on this axis we've got v, and we are interested what is happening if v approaches a specific value equal to n, then v can approach this value from two sides. Look, first of all, we can see that starting from smaller values than n, we can get closer and closer and closer and closer and closer to n from the left-hand side. And in this case, when we will be calculating this limit in this way, we will say that we have left side limit. But, of course, we can start from the opposite direction. We can start from values that are greater than n, and we can decline v until we're going to arrive at n. In this case, we're going to say that we are calculating right side limit. Okay, so now we will use a different denotation when we're going to approach n from the left hand side, and a different denotation when we're going to approach n from right hand side. And look, when we're going to approach n from left hand side, we're going to write limit with v approaching n, and we're going to add minus out of q, right? This minus denotes the fact that we are getting closer and closer to n, but from values lower than n. And consequently, if we're going to approach n from values bigger than n, we should write limit with v approaching n with plus over here. Okay, so now that we know this, we can say when the limit actually exists. And if limit with v approaching n from the left hand side is equal to limit with v approaching n from the right hand side, and this is equal to some L, and this L is a finite number, okay, now what is a finite number? Well, finite means not infinite. So look, if our answer is neither infinity or negative infinity, we are getting a finite number. This is a constant, basically. We are getting some value, and in this case, we can say that limit with v approaching n, and this is going to be equal to limit with v approaching n, and this limit exists, and it is equal to the finite number we've been talking about. Now look, if it's gonna happen that limit with v approaching n is equal to either infinity or limit with v approaching n cubed is equal to negative infinity, then this implies that limit does not exist. So, generally, we will have a situation in which q expressed as a function of v is unbounded. So it either increases to infinity as we get closer to n, or it goes to negative infinity as it gets closer to n. And look, in this circumstance, we should also notice that if left-hand side limit and right side limit are different, then also limit does not exist at, of course, this point N. Okay, but look, our considerations thus far should lead us to yet another point. Well, this point is that in some circumstances we cannot calculate limit from the left-hand side, and in some situations we cannot calculate the limit from right-hand side. Okay, and look, so let's just say that here we've got v axis, right? And look, our n doesn't need to always be a specific constant. For example, let's just say that I want to calculate limit with v approaching infinity out of q. Okay, now look, where is infinity over here? Well, it's somewhere there, right? Where exactly, we don't know, because this axis will go on forever, but it will never reach infinity. So, can I actually approach this? Can I approach infinity from the right hand side? I can't. So look, in this circumstance, we can calculate only left side limit. Now, on the other hand, if I would like to calculate limit with v approaching negative infinity, then where is negative infinity? Somewhere there. How far? We don't know. Probably very far away. Can I approach negative infinity from the left-hand side? No, I can't. So in this case, we will have only right side limit. Okay. So, look, I'm going to actually stop at this moment where we actually only covered a very, very basic information about the limit. And in the next video, we're going to move to graphical interpretation of limits. Okay, see you in the next video.